Hello everyone. I hope you are all doing okay in these difficult times, and my advice to you is that you should just lock yourself up into your shed and build something great. Anyway, in this video I like to show you how I made the crankshaft and crosshead for my new solar steam engine. Okay, so I will make the crankshaft out of this piece of 15 by 25 millimeter steel, and I'm going to drill an 8 millimeter hole in it and a 12 millimeter hole. In the 12 millimeter hole is where the crankshaft itself is being glued in or welded in. I'm not really certain what I'm going to do there. And I'm using a 12 millimeter because well, the length of the crankshaft will be quite long, maybe about this long. So if you use an 8 millimeter crankshaft, that would undergo a lot of torsion. That makes the transfer of energy less direct, so I'm using a thicker, more strong 12 millimeter crankshaft to have more stable energy transfer. So let's now drill the holes, and the most important part is that these holes need to be absolutely parallel. So I'll just put it in the clamp and I will drill both holes and then I will get it out, so there's no difference in parallelity, because that of course will make a huge difference. So let's drill some holes. Okay, that went surprisingly well, because most of the times these holes, when you drill them, they tend to drift to the side. And well, that's why I first drilled these small 4 millimeter pilot holes. Then I drilled both holes to 7.8 millimeters, and then I only had a 11.5 millimeter drill for this hole. Ideally you would use an 11.8, but I don't have a drill that size. Then I put an 8 millimeter reamer through this hole and a 12 millimeter reamer to this hole. So now it's all nice and parallel. If I now measure the holes, it's 10.4, so the crank is a little bit longer, about 4/10 of a millimeter, but it's not really a problem. And that's actually the reason why I made the cylinders a millimeter longer than needed, because if you don't use a lathe or a mill, it's of course hard to make stuff accurate. So if you can't make it really accurate, then you need to build in room to adjust. So I'll now round out the end here, and I will leave this a bit longer so I can later weld on counterweights and make a nice round shape like it's supposed to be in a steam engine. Then I will glue in the main shaft and the piece where the cylinders will attach to. I'm not really sure what that's called. Maybe one of you guys know that. And I will leave both of them too long and I'll later cut them to the right size when I know what the size is going to be. So let's get to work. So these parts are now ready, and I will now glue in these pieces with Loctite, but first I will take care of this before I bleed out. So, much better. We'll now degrease these rods and the crank with cellulose paint thinner and then glue it together with Loctite. This is Loctite 638, which is the high strength kind. I will first glue it with Loctite and I will see if that holds, and if not, then I can always weld it. But if I need to change things later, I can just heat it up to over 120 degrees Celsius, and then the glue will disintegrate. You can get it apart easily. So let's glue it together. Okay, so the crankshaft is now ready and all nice and perpendicular, so that's really nice. I left it way too long because then I can always make it shorter, because it's much harder to make it longer. And well, the bearings are in now, and I can push this through. And of course, if I completely push it through, then it will slide over this plate. So I need to make a little spacer where it can rest on nicely. And I also need to make a spacer for this one, because if you turn it around like this, it will hit here. So I'll make a small spacer out of copper pipe that I have lying around. And there's not much force going in that direction, so a bit of copper is okay, although steel or brass would be better. But for now we'll use the copper ring. And there are going to be 3 of them on here. So then they will turn the crankshaft around like this. It's going to be really nice, I think. So let's make the spacers. And I have here this pipe cutter. And I'll just cut this pipe with this cutter, because then it will be nice and perpendicular again. This is just a piece of installation pipe, which has a 12+ mm diameter on the inside and 50 millimeters on the outside, so that's perfect. Very nice. So now this part is straight. I will cut the other part, and it's boring, so I'll just cut to the end result. Okay, so the rings are ready now, and I already shoved them on here. This ring here, this ring here. So now, even if I push, you'll still have some distance from this plate. These thingamadoodas can go on here, so then they can go like this, and I'm such a nerd. Okay, so now it's time to make the crosshead, and this is going to be screwed on here after I've shortened it and threaded it. So this is going to be the position, and now I need to make a fork that fits around here, and I can put a pin through it to fix it, and to that fork I can attach another rod which goes to the crankshaft. So another one is going to be here. So let's make it. Okay, so to bend this steel strip into a fork, I'm going to bend it in my vise, and I'm going to use the 2 steel strips welded together. This is 12mm, and I have here a piece of saw blade, which I cut also at 12mm width. So if I place this at the end of this, then this end is protected, because if I bend around this, normally this would dent a lot. You don't get a really nice and tight bend. So with this piece on top, this bend will be much tighter. I use this steel block as an anvil, because I will hit in this direction. Then of course if I put it in like this, I will hit it out of the vise. So this, it's an anvil. You'll see what I mean. Okay, so now let's pound it gently into the right shape. Okay, so these are now ready, and now I need to thread the piston rod. So let's cut these and thread them. Okay, so the pistons are glued onto the piston rods. This plate is fixed on here with double-sided tape temporarily, so there's a millimeter of extra spacers, but I can later adjust that. So I'm now going to determine the length of the connecting rod, and well, you can see I jazzed this up a little, so it looks a little bit nicer. And this is going to fit on here. This pin is going to go through. This just temporarily because well, this just nuts. So I'm going to fix that in another way. And now, because it's in the outer position, and if I turn the crankshaft to this dead end, then I can measure the distance between these two parts if my calipers fit in between. That seems about right. So that's 78 millimeters. And if I now push this in completely, turn the crankshaft the other way, then this should be more or less the same distance. So it's a little bit more, which means that the stroke of the cylinder is about 3 millimeters longer than the stroke of the crankshaft, which is good, because then we have a little bit of slack. So if I now make this connecting rod the average of the two, so the other one was 78 millimeters, and this one is probably like 81 or something. 81 exactly. So I am going to make the length of this connecting rod the average of the two measurements. So I will cut that off now, thread it, and then we'll see how it fits. Okay, the connecting rod is finished, and I have grounded off the sides of this nut and of this ring. So this will now fit in here. And this too. Okay, it needed a little bit of kinetic motivation, but the nut is now in. This is screwed on here now, so I can now screw this in this rod end. And I can temporarily fit this in here. So now it's linked together. So now I need to do the other cylinders, and then I weld these plates on at the correct height. Okay, so I've now tack welded the mounting plates for the cylinders onto the frame, and I will now drill the holes through the frame so I can firmly attach the cylinders. Okay, so everything is now where it's supposed to be, and well, it turns quite nicely. And you can see that these rods are threaded in here because I couldn't fit a nut here. Maybe later I will fit a nut here, but now the weld is in the way. Or maybe I'll just glue this in with a bit of Loctite. Enough to fix it, but not enough that I can't get it out later. And this one is the high pressure cylinder, which is just bolted on as I had planned. And the low pressure cylinder, I needed to grind away a piece of this crossbar, so the nut could fit in here. So those are the only adjustments I did to the frame. So now I'm going to make the support for the crosshead to take care of the side forces. I'm going to make the crosshead support out of this POM or polyoxymethylene, very often used to make bearings, and it manufactures very well. So I hope this way I don't have to use too much lubrication, because this together with metal already lubricates itself a little bit. But instead of Teflon it's quite hard, so that's why I use this. So let's cut off some pieces. Okay, so now I've cut up all these pieces. So I've here these 5mm steel plates and the POM, and I filed and sanded these so they are all the right height and they're parallel, which was a lot of fun. So this is going to be set up like this. I'm going to bolt this on, and then the crosshead is going to be in here. There's going to be another part on top of this. And then with steel strips I will connect these two. So you have one cassette, if you will, where the crosshead will fit in. And then later I will weld it into the frame so it's at the correct position. So we'll now drill holes. So we'll do a quick time lapse of everything, and then we're going to fit it in. Okay, so these are now finished, and well, because welding is never very accurate, this round piece sticks a little bit in here. So with a file I will then remove a little bit on both sides, so it will fit nicely. Okay, so these are now ready. It fits in here quite nicely. It's nice and tight with a little bit of slack, so that's nice. Now this is going to fit in here like so. So let's put it all in. Now we'll bolt this to these strips. Okay, so the supports are now all attached, and I could bolt them all on to the frame, except this one, because the high pressure cylinder sits so high up on the frame, so the crosshead support also had to be high up on the frame. So I welded an extra piece in here so I could bolt it on, and after it was all bolted on, then I loosened up these rods so I could move these a bit so it would have the least amount of resistance, because it's of course quite hard, because you have now 3 points with which the piston rod needs to align. So because this can move a little bit, I can compensate for those errors. Okay, so far so good. In the next video I will make the valve gear, and of course of all the parts I made in this video I will make drawings which I will post on Facebook and Instagram, and we will put a link in the description and in the comments. Okay, that's it everyone. Thank you all so much for watching. Please like, share and subscribe. Click the notification bell. Stay safe and healthy, and see you next time.